Hello and welcome to lesson 4, video 2, the lesson 4, video 2, the sample problem video for Precalculus 1. And in this video, we're going to do some examples of linear equations, linear inequalities, and absolute value inequalities. And so again, with a lot of these, you might be able to get through them pretty quickly. Um, again, I would probably, once I post the problem, I would hit pause, try and work it out, and then, kind of double time it through or something to make sure you have the answer correct. So for these first few, we're going to solve for x. And the first one, we have 3x plus 17 is equal to 8. So we have to do what? We got to get rid of the 17 first. So subtract 17. And as I warned in the first video, just be careful with the arithmetic. So I have no doubt that you guys are probably capable of doing these linear equations, but it doesn't mean that you guys always get them right, because it's like little mistakes that get you. So just be careful. So 8 minus 17 is negative 9. And these guys cancel out, so we have 3x here. And then divide everything by 3. Negative 9 divided by 3 is negative 3. And of course, if this is on a test, you can always check your answer and plug it back into the original, see if it works. So if I plug in negative 3 into the original equation, 3 times negative 3 is negative 9. Negative 9 plus 17 is 8. So I'm 100% sure that's the correct answer. What if I have 2x plus 3 is equal to 4 minus 3x? Well, same thing. I have to get all the x's by themselves, all the constants by themselves. So we have a couple ways to do this. If I want, I can move all the x's to the left. That sometimes makes it easier, because then I end up with an answer like x equals negative 3. So it's a little easier for me to sort of comprehend. But you can move them either way you want. I have minus 3x, so I need to add 5x, add 3. See, there you go. Be careful. I know what 2 and 3 is. It's 5, and I wrote down 5. And that's the little things that kind of happen. So, even your math teachers, we're not perfect, especially as I'm trying to do this video. So just be careful. Add 3x gives you 5x, and then bring this guy down still. That's the other thing I would recommend, is do one step at a time, because where I see a lot of errors come in is you guys are trying to do everything all in one shot. So you're doing a lot of math in your head, which is never a good idea. So we do what now? Now I'm going to subtract 3 from both sides. So these cancel out. So I get 5x. 4 minus 3 is 1. And then divide everything by 5. X equals 1/5. Uh-oh, I got a fraction. So what? So you got a fraction. You might get a decimal. You might get, some really odd looking numbers, but that's okay. In real life, very rarely does it work out to nice answers like negative 3 we had in the first problem. If you get a fraction, it doesn't mean it's wrong. It just means that we got a fraction as an answer. And then lastly, 7x plus 2 minus 6 times 2y minus 1 equals 2 times 3 minus y. I'm sorry, not y, x's. 3 minus x plus 2. So 7x plus 2 minus 6 times 2x minus 1 equals 2 times 3 minus x plus 2. So this one is now testing a lot of the stuff we've done so far, right? So we're going to have distribution. It's still a linear equation, because all of these are just x to the first power. And so we got to get rid of the parentheses first. So I have what? 7x plus 2. Now here, distribute the minus 6. So this is minus 12x. Negative 6 times negative 1 is plus 6. And over here, distribute the 2. So 2 times 3 is 6. 2 times negative x is minus 2x. And then we got this 2 hanging out on the end here. So combine our like terms. So here, 7x minus 12x is minus 5x. 2 plus 6 is 8. And then over here, minus 2x, 6 plus 2 is 8. So now I can add 2x to both sides. So I get negative 3x plus 8. These cancel out is equal to 8. And then subtract 8 from both sides. Negative 3x is 0. Well, that's okay. So divide everything by negative 3. So we get what? Negative 3x is equal to 0. Divide everything by negative 3. These cancel out. X is equal to 0 divided by negative 3. 0 divided by anything is 0. So this is an issue for some of you guys. Like you give me an answer, 0 over negative 3. Okay, well, what is that? Because you're not sure. Is it 0 or is it what we're going to learn next lesson, undefined? So 0 divided by any number. So 0 divided by any number is always equal to 0. Think about it like if you have like 5 people in a room and I have $0 in my pocket and I want to divide the $0 by the 5 people in the room, how much does everybody get? They get 0 because I don't have anything in my pocket. So that's what they get. They get 0. So 0 divided by any number is always going to be 0. And that's our answer on this one. X is equal to 0, which again is okay. It could be a real number. It could be a fraction. It could be 0, which is also a real number. But so again, the numbers don't always have to be nice integer numbers as our answer. So that's our linear equations. So now let's move on to solve the linear inequality. And we want to write our answer in interval notation. So this goes back to lesson 1. When we write things in interval notation, it needs what? A parenthesis or a bracket. If our final answer here does not have a parenthesis or a bracket, it's not right. We want interval notation. So the first one, let's say we have 3x is greater than 4. Well, we still solve these like as if they were regular equations. So to get the x by itself, divide by 3. Since it's a positive number, I don't have to worry about reversing the inequality. So that means what? X is greater than 4/3. So if you want to use a number line, that's fine. 4/3. It's an open circle because it's strictly greater than, going to infinity. So my answer would be what? Parentheses 4/3 to infinity. What if I have 2x plus 13 is less than 3? Hey, bud. So I do what? I have to subtract 13 from both sides. So it's okay if I'm subtracting a number. That doesn't affect the inequality symbol. It's only multiply or divide. So when I subtract 13, I end up with 2x on the left. 3 minus 13 is negative 10. Hey, leave him alone. Hi. My buddy's here to see the class. You want to be on TV or on video? Here, look. Here's Grayson. Hi, what do you want? Water? Okay, go get a drink. All right, little break from math there for you. All right, back to the problem. So we have what? Divide everything by 2. It's a positive number, so I don't have to reverse the inequality. So negative 10 divided by 2 is negative 5. So again, if I want to put this on a number line so it makes sense to me, it's strictly less than, so it's an open circle going to negative infinity. So it'd be what? Negative infinity to negative 5 with a parenthesis. Number 3, 3x minus 6 is less than or equal to 6 plus 9x. So again, same idea as a linear equation. It's just we have this inequality. So I'm going to subtract 9x. So that gives me minus 6x minus 6 is less than or equal to 6. Add 6 to both sides. So negative 6x is less than or equal to 12. And now to get x by itself, I have to divide by negative 6. So before I even keep going in the problem, like, uh-oh, dividing by a negative number, I have to switch the inequality. And go ahead and finish it off. So divide that, I get x. 12 divided by negative 6 is negative 2. So if I draw this, I'm at negative 2 greater than or equal. So it's included, closed circle, going to the right. So that's what? That's bracket negative 2 to infinity. And then the last one we have here is one of those two-parters. So 5 is less than or equal to x plus 9 is less than 7. So we see we have a mixture of symbols. That's okay. But to get x by itself, we do what? I have to subtract 9 from everywhere. So 5 minus 9, negative 4. 9's cancel out. I have x in the middle, less than 7 minus 9, negative 2. So this one, it might really help to draw the number line. So when you convert it to interval notation, you're doing it correctly. So I have what? Negative 4 down here. It's less than or equal to x, so therefore it's included. So it gets a closed circle because of this line here. And then negative 2, but it's not included, so that's open circle, and it's everything between. So in interval notation, this is what? Bracket negative 4 to negative 2 with a parenthesis. So if it's asking for inequality notation, that's it here. But on the test, it's going to ask you to write it in interval notation. So that's everything between negative 4 and negative 2. Negative 4 is included, negative 2 is not. So close circle, open circle, which means bracket and parenthesis. And finally, we have our absolute value inequalities. So solve the absolute value inequality. And write your answer in interval notation again. So the first one we have absolute value of 4x is less than 12. All right, so we have those two types, right? Less than or less than equal means we do what? We set it up as the two-parter. So this guy, the 4x goes in the middle. We use the same symbol that we have here in both cases. And then it's plus and minus this guy. So positive 12 here, negative 12 down here. So I divide everything by 4. So I get negative 3. 4's cancel out. X, positive 3. So again, on a number line, what does that look like? Well, -3, +3, neither one are included, so it's open circle. So it'd be parentheses -3 to 3. And you can check these. So these are not super simple. And it might be like, wait, do I do it this way or do I have to set it up as two separate ones? So if we're saying this is the answer, then if I pick any number in this interval and test it in the original, it better work, right? It better be true. So an easy one to do is what? 0, right? 0 is between -3 and 3. So if I plug in 0 here, 4 times 0 is 0. Absolute value of 0 is 0. Is 0 less than 12? Yes, it is. So then I can be pretty sure this is the correct answer. Conversely, if I have, let's say 3x, absolute value of 3x is greater than or equal to 15. So when it's greater than or equal, this means it's getting away from 0. So that means what? I have to do 3x is greater than or equal to 15, or 3x is less than or equal to -15. We have to set these up as two parts. And again, this is or. So divide this one by 3. I get x is less than or equal to -5. And divide this one by 3. I get x is greater than or equal to +5. So what does that look like on the number line? Well, it's -5 closed circle going to -infinity. It's +5 closed circle going to +infinity. And again, if we want to test if this is right, pick a number down here. Let's say -10. If I plug in -10, 3 times -10 is -30. Absolute value of -30 is +30. Is +30 greater than or equal to 15? Yes, it is. So I know it's definitely this line here. Or if I do +10, I get the same result. So it's here. So now the question is, okay, well, this is my picture, but George, how am I supposed to write this in interval notation? And this is where it's going to get a little bit tricky for us, except that we have what? We have this word right here, which is or. And remember back to the very first day, what does or mean? That means union. So it's everything here, -infinity to -5. -5 is included because of this closed circle, or union, 5 with a bracket going up to +infinity. So we're not looking for the overlap here, we're looking for the union. So it's all of these values or all of these values. So in interval notation, it's -infinity to -5 with a bracket, union, bracket 5 to infinity. And again, infinity always gets that parenthesis. So that's it. Those are the types of problems you're going to need to know for the homework set. So good luck, and we will see you guys on the lesson 5 videos.